Hey, Gauri, you there?
Yes, I'm here.
So,
Shall I start?
yeah, we can probably start with a little bit of your introduction, and then, you can give people a little bit thorough idea of what is going to be today, and then we can kickstart. I guess by then 2-3 minutes will be there, and
Sure.
6-10 we
No
can
problem.
start.
Sure.
Okay.
No problem. Good evening, everybody. This is Gouri Sohoni, and I welcome all of you for today's session. Today, I'm going to talk from the perspective of on the version control, and the focus on the version control is going to be with the help of Git. I'll be showing you a few of the demonstrations. I will mainly talk about the basic concepts available with Git, like what is the repository, what is cloning of the repository, what is commit, and a little bit details about sync operation, pull, push, and finally a little introduction about branch and merge. This is going to be what we will see as a part of the session. Let me give a brief introduction about myself. As the slide says over here, I am Gouri Sohoni. I am Microsoft Most Valuable Professional, and my area of expertise is Azure DevOps. I'm also Microsoft certified trainer, and I have given certifications on Azure developer as well as Azure DevOps engineer. So I do give a lot of trainings and consulting on behalf of Microsoft. I do write a lot of articles on various sites, and I'll share where I write the articles. And this is a new thing which I am doing as far as happy hours is concerned. Earlier, I had given presentations on behalf of Microsoft, which was as a part of Azure with Dapit, and I'm very happy to provide a small session on version control today. So I'll wait a bit, a minute or two, and then I'll start the session right away.
Sure, Gauri, and like I've mentioned in the starting, everybody will try to put their questions in the comment section rather than interrupting during the session, and maybe during the maybe half of the slides or after, like whenever you feel there's a time for a logical break, you can just go through it and maybe cater those queries, and then completely we can take those queries later once the session is over. And
sure.
By the rest of the time, we have Himanshu and Kunal to take care of those queries and everyone.
Queries. Okay, perfect.
Thank you.
So let me start with the session discussion. So I have already discussed a bit about myself. I have been in training field for a long duration, and let's go straight away into what is a version control, and then let's see what we have with the help of Git. So I assume most of us will be aware about what is a version control. So version control is basically a software which will help the development team tracking the changes they make in the code when they are developing a project or a product. So I assume that everybody must be using at least one or other version control system. So if there is no version control used, then team members may have to keep multiple copies of the code, and in which case it is always there is a fear of changing the wrong copy, overwriting the changes done by some other user, and in this whole process we might end up in losing some of the valuable time, as well as by overwriting the code we might end up losing some of the code. So in order to avoid all these situations, most of the development tools, development teams work with the version control. So having given this a little bit introduction about version control, let's go into a little bit details about what are the main two types of the version control. So there are mainly two types of version controls. Version control, one is called as the centralized version control, which is the traditional version control, and the second one is the distributed version control. So what do we understand, and or what are the different benefits of each one of these? So let's go a little bit into each one of this. So excuse me. Centralized version control has its own pros and cons. So let's have a look at the different tools which are supported from the centralized version control. So as we will be going into details about Git as a version control tool and which is implemented with Azure DevOps, so being a Microsoft product. Microsoft also supports a tool for centralized version control, which comes with the name as Team Foundation Version Control, or which is commonly called as TFVC. There are other tools which are given into the slide over here, like there can be a SVN as a tool, or CVS tools, ClearCase, or Team City as the tool. Depending upon the requirement and the need, the development team decides which is the best suitable option for the version control. First, the choice will be amongst which will be the suitable choice for us, depending upon whether we want to go in for the centralized version control or we want to go in for the distributed version control. Having selected this choice, then depending upon other requirements and depending upon the budget and other details, we can think about whether I want to go for SVN, CVS, ClearCase, Team City are the different tools available. So the tool which is available from Microsoft as far as centralized version control system is concerned is TFVC, or Team Foundation Version Control. So after having a look at different tools which support centralized version control, let's talk about what are the different pros and cons of centralized repository or centralized version control system. So I have created a slide based on this. So here you can see there are a few pros and there are a few cons specified. So as far as pros are concerned, this is very easy to understand. If people are already conversant and already working with centralized version control, it is very easy to continue with that. There is a bit of a learning curve as far as changing of the mindset from centralized version control to distributed version control. And when we will go and have a look at the distributed version control and the some of the features available with it, we'll find out yes, there is a little learning curve required. So there is another facility which is available is there is an exclusive checkout by default. So when the code gets checked out, it can be exclusively made available to individual team member. That means that also means that a particular team member, if has locked the code, that code will not be made available to any other developer or the team member. This is ideal in situations for large files and large repositories. Having said that, Microsoft has also taken care of putting their large code base, which is huge code base with Windows, and they have implemented it with Git also, and they have added certain additional functionality with Git. But as far as the centralized repository is concerned, this is suitable for large repositories. But it also comes with a few of the cons, wherein there will be a single point of failure because we do not have multiple repositories. Every team member will be working with the repository which is available into the source control. And whenever we want to do any changes to the code, we always have to be in the connected environment, which also makes the centralized repository or centralized version control a little bit slower. So having looked at a little bit information about what centralized version control offers us, let's go and have a look at what is available with the distributed version control or distributed source control system. So with distributed version control system, like I have already mentioned, there are various tools provided which will be supporting the DSVS or DSVC, which is called as Distributed Source Version Control System. And these are a few of the examples for the tools. So as far as Git implementation is concerned, Microsoft provides it in two ways. One is there is a inbuilt support with Azure DevOps, which is from which comes with the name as Azure DevOps Git. Then Microsoft has also taken over GitHub, and from Azure DevOps, I also can fetch the data which is stored as a part of GitHub. So there is also GitLab, there is Atlassian Bitbucket, there is some other implementation, a little different implementation of Git available with Mercurial, Fossil, or GNU Bazaars. These are some of the tools which will be supporting the distributed repository or distributed version control system. Let's go into a little details about what we have with distributed repositories. So like with centralized repository or centralized version control system has its own pros and cons, distributed repository or distributed version control system has its own pros and cons. This becomes very fast, and the reason why distributed repository becomes fast or distributed version control system becomes fast is every team member is having a copy of the repository, or which is commonly called as repo for the local interaction. So whatever changes made by the team member will automatically be getting written into the local copy, because of which it is going to be very fast. And this is the reason why distributed version control system becomes very fast, because every team member is having his or her own copy of the repository or repo. There is not going to be a single point of failure. So somebody will have the copy of the repo, or many people will have the copy of the repo, and then we can use it, and then further we can say that there is no single point of failure. This has a lot of options, and that's why it has become a industry standard. But as I mentioned a while back when I was discussing about centralized version control system, people who are comfortable, conversant using with centralized version control system find a little hard to change over to distributed repository, because there is a bit of a learning curve. You need to follow certain best practices. So certain best practices will come in terms of whenever you are creating a branch, you are pushing the branch to your repository, which is a remote repository. You need to create a pull request with the help of which the review of the code needs to be done. This is one of the best practices which I can specify. Handling of the binaries is a little difficult with the help of distributed repository, which is the implementation which we are going to talk about with the Git, which is available as a part of our Azure DevOps. Let's go a little bit into the different basic operations which are available with the help of distributed version control system. I'll give you a little bit of concepts first, and then I will show you some of the demonstration to directly connecting to Azure DevOps, creating a team project over there, and then I'll show you how the cloning will work. So let's go into the operations one by one. So first thing we need to do is every team member or the developer who is to work on the repository, the remote repository, needs to clone the entire repository on his or her machine. So this is the first thing we need to do. So here we can see that there is a pictorial representation over here which tells us that there is a repo available into my server, which is my source control repository available with Azure DevOps, and the entire repository will be cloned on my machine when I want to start working with the code. So any changes I want to make to the code, I want to have a look at the already created code by other team members. So it creates local repository if it is not existing, and it sets the link to the remote repository. So you can see that there is a command given in case I want to use a git excuse me I want to use the command line utility to give the command. You can see that the last statement which is added, which is a command line command which I can provide for git clone. So the command says I'll have to give git clone followed by the repository which I want to fetch, followed by the last statement or last step of command you can see is the place where I want it on my machine. So it is in this case under repos under Fabricam Fiber as the name. So this is the first thing which we need to do when we start want to start working with the repository. So we create the clone of the entire repository. Next thing we can do is whenever we are finished doing some changes, those who have worked with centralized version control system must be aware that we check in the code. In this case, we do not check in the code, we call it as code commit, and committing of the code is always to the local repository. Because the code is committed to the local repository, it will be very fast. All the files will be getting committed, or the staged files. I'll show you how the difference between the files and the stage files is. And every commit will have its own unique ID. Every commit also needs to be associated with the commit message, and obviously this commit message needs to be a descriptive commit message and not commit 1 commit 2 like this, which should help in understanding what our code is specifying. So that should be the commit message. So another command which is mentioned at the end of the slide is git commit m as the parameter followed by the commit message. So as I said, the commit message needs to be a descriptive one. It should be a one which will be giving us some information about what is the code which is being committed by the team member. So commit is always happening onto the local side. So with this, I'm going to show you a small demonstration now. So let me come out of the slide deck and show you my connection to the Azure. So I'm going to go to dev.azure.com. So this is where Microsoft provides the Azure DevOps, and I'm going to select one account with which I have I'll be working with later. So let me quickly show you a few of the steps which I have showed you, which I showed you with the help of the PowerPoint presentation. So this is an organization which I have already been working with. This is with the name as Gouri Sohoni, my name for the organization I have given. The hierarchy of Azure DevOps is there is an organization. Within the organization, I can create a project. The process for the project can be Agile, Scrum, CMMI, or Basic. So let me give the name of the project as say Happy Hours Project. And quickly select the Git as the version control because that's all will be working today. And I will select this Scrum as a process and I'll click on create. So till the time the new project is getting created, let me also start the Visual Studio. I have shown you with the help of the presentation that the repository can be cloned by git clone as a command which can be given from the command prompt. But while using with the help of Visual Studio, it will be pretty straightforward to clone or the check out for the code. So let's see if the repository is team project is ready. So this is the team project which got created right now. If I go into the repos as the option, so this is what I was talking about as the remote repository. So this remote repository is automatically created because we haven't added any code. This is the first time I am creating it. There is no code. I have the option of cloning it with the help of all these different choices. So I'm going to go to Visual Studio and straight away select the option of clone or check out the code. And where will I know my code to check out is, I know it that I am having it with the help of my Azure DevOps, and I'm using the same account with which I have connected to the Azure DevOps, and I know where my organization is. So this is a organization which I am having. Earlier, Microsoft used to call DevOps, Microsoft DevOps as visualstudio.com. So this was a organization I had created at that time. That's why we still see it as gaurisoni.visualstudio.com, and it doesn't appear under dev.azure.com, but it's the same organization I'm connecting to. The moment I click on connect, I get to have the option of clone the repo. So the cloning of the repository, which I was showing with the help of the git command, I can do it very quickly with the help of the Visual Studio, and you can see that the same clone repository is given, which is my remote repository. And where will it be cloned? It will be cloned somewhere onto my local copy or my local machine I am working with. So once I have created the clone of the repository, then I'll be able to write the code. Normal situations, somebody already has written some code into the repository, and that code will also be getting downloaded with the help of the repository cloning which we do. In this case, because I created the repository right now, there is no code. So let's add some code into it, and then I'll show you how commit works. So let's click on this new as the option, and I'm going to create a new solution. You can see that there can be various options with which a new solution can be created. I'm going to select this ASP.NET Core Web Application, click on next, and I can give the name for the web application. Okay, giving the name and all, it's not that important. What is important in this case is how do we make use of the commit and all other related basic operations. So I'm going to click on create over here. So the template for ASP.NET Core Web Application is being selected, and it will create the code for me. If I go to the Solution Explorer, you can see that it has added quite a number of files over here. Now let's talk about how will we commit the code. So we have seen two functionalities already. I created the repository onto the server, which in this case is my Azure DevOps, and then I cloned it into my local copy, which in this case is the laptop on which I am working with. So now I have the option of going to change, and we will see that there are a lot of changes which have been made. These are all with respect to the ASP.NET Core application which I have added. There is one more facility or feature which you can add. I can quickly go to this settings, go to the repository settings as the option, and see that there can be certain files can be ignored. So PDB kind of files or DB log kind of files, I don't want them to go as a part of my source control on my server side. So I can add this, and those files will be automatically getting ignored. So if I go back to the changes again, so now you can see that earlier I was seeing 90 changes. Now suddenly the number of changes have reduced a lot because I removed some of the files which are not required in my source control. You will also see that the git ignore file which got added is automatically put as a part of the stage. So this is what I was talking about. What do we put it, whether we put it into the stage or we directly commit it into the code. So I'm going to do it in the same process or same step, that I'm going to add all these 60 changes into the stage, and then we will be giving a commit message. I showed you the functionality wherein the Git commit can also be specified with the help of the command. I'm doing it with the help of my Visual Studio Code. So like I specified, your commit messages should be self-explanatory. So web application created is the message which I have given over here. And when I click on the downgoing arrow for commit, you can see there are a few of the uh, options available with commit. So commit stage is going to commit it to my local copy of the code. So I'm going to click on commit, and you will see that this is the commit ID which gets automatically created. Now I'm going to go back to my Azure DevOps. I'm going to refresh this and see that I see if the code is available over here. The code I committed, but it was not sent to the server. So that's why we can see that it's no more available, or it's still not available into my server side or my remote repository, because I did not push the code, or I did not select the option of commit and push. So at this stage, I'm going to take a small pause and see if there are any questions, and then I'll continue the discussion further. Okay, let's quickly go here. Okay, is there a list of file extension that need to be ignored while checking in? You can go to the ignore file and you can see the list of extensions already there. And in case you want to add extra, you can add. Is there a list? Is there a list of the file extension that need to be? Okay, that's done. You can drop your question. Okay, I understand. The question was here. Is there any specific type of extension that should not be checked in? Okay, so it depends upon, for example, the PDB file is the one. You can add whichever extensions you do not want to be checked in as a part of the git ignore file which got added. So then those extensions, whatever you provide as a part of the git ignore file, will not be checked in. So that's the answer to the question Manoj Kumar has specified. So, okay. Fine. So let me continue the discussions on the same lines, and you can add any file you want. No need to ignore any. Okay, sorry, that was the answer. Let me go back to sharing of my screen again. So this is where we were. So here what I showed you was how to locally commit it. So now that I have committed the code locally, what are the ways with the help of which I can send it across to my remote repository? So for that, I can make use of the sync option over here. And with this sync option, you can see that I'm already having the one commit ID which I have created a while back, and I have the option of push over here. If I would have selected the option of commit staged and push, both the things would have happened in the same step. But because I wanted to show you the difference between commit locally and commit and push, I did not push it earlier. So let me click on this push as the option, and once the push is successful, I'll go back to my remote repo and I'll show you that yes, it is available. So this is where my remote repo is. Let's quickly refresh this, and you can see that now, excuse me, the code is available. So this is the git ignore file which gets created on by default, and as you can see, you can add a bit of the code which you want into this, or you don't want a particular file to be added, so you can put it into the git ignore file and continue working with it. So that was about commit and that was about push. So let's go to the next So I discussed push. So what does push do? Pushes it from the local repository to the remote repository. By default, all commits will go. It creates a remote / origin onto your local copy, and then as you can see with the help of the small icon shown over here, and the complete commits will go and sit as a part of my remote repository. So this is a command with the help of which the push will be given. The way there is a push operation, there is a pull operation. So why do I need a pull operation? If some of my team members have done some changes and they have committed that changes, that is they have committed and pushed their changes, I would like to know about what changes have been made by my team members so as to continue writing my part of the functionality. So in that context, I can make use of the pull operation. Pull operation gets the code that is pushed by other developers. It immediately merges the code directly with the respective branch. I'll talk about branch in a while. So for the time being, we are having only one part of the functionality which is being written with master as the branch, and it will automatically be getting merged with the help of the code which is available in the in the master branch, because currently I am the only person who is working in my repository, because this is the repository which I have created a new, and nobody has yet committed any code from or my team members haven't pushed any code. In case the branch is not available on my side of the code, the new branch will get created if it doesn't exist, and that's a functionality where we can see the command line utility, which is git pull followed by origin followed by user / name of the user and whatever is the branch I'm trying to pull. So let me quickly show you how this works, and there is another operation which I want to talk and discuss about, which comes with the name as fetch. So what I'm going to do is I'm going to try and be a team member. Currently, there is only one person which is in my which is associated with my repository, but I'm going to play the role of both. So let's say I go into this views and okay, not views. Where do I do some change? Okay. Yeah, that seems fine. So let's say this is a file which I want to do the change. Let's say there is another team member. So I am putting myself into the shoes of another team member. And because I am having the direct connectivity to the browser and I am directly working with my remote repo, I'm going to go and edit this here itself. So here the address you can see is being shown as one Microsoft way. Let's say we put it as happy hours and do the change. I've told you that commit is required from the local side. Local commit puts the code into the local copy of the repository. Where is this commit happening? This commit is happening directly on my server. So if I give commit, here also you are supposed to provide the comment with the commit, and it will automatically be getting updated in my repo in the remote, because I'm directly working on my server itself. So let's click on commit over here, and there is one change which I have made. Now let me show you by going to commits that there are two commits. One which I had given a few minutes back from my Visual Studio when I pushed my code, and this is the one which I have currently changed. So now I want to show you another part of the functionality, which is fetch. So you can see there is a pull, there is push. It's not enabled because I have not written any functionality as of now. So fetch is an operation which will fetch the change data, but as I told you, with the help of pull, it will not be automatically getting merged with the help of my local copy. So if I fetch this, it will fetch the remote commits, and let's see what happens later. So this is the fetch it has done. I am going to double click on this. It shows me this is the file which has changed, and the file, whatever the changes are, I can see it with the help of the diff tool, which is available with my Visual Studio. But the changes are not yet merged with respect to my local copy. So in order to merge the changes, I'll have to make use of the pull. So I'll go over here, I'll go to sync, and you will see that there is a fetch option which I have already tried and showed you. When I click on pull, and when I then go back to this new file, the file which I have done the changes to, the change will be reflected into that. So pulling will automatically be merging it as a part of the changes into my local copy. Now if I go to Solution Explorer, I go to view. Yes, this is where I did the change. So now you can see that the change which I have made with the help of directly on the server is now reflected here. So this is the difference between when I am working with pull, push, and merge. Let me quickly go to the slides and show you what we have as the next operation. So we discussed about push, we discussed about pull, and this is the fetch operation which I showed you a while back. So fetch gets the code that is pushed by other developers, but the code does not get merged. So we have already seen that a remote origin gets created on my local side. So it is the remote origin which will be putting this merge code into that, and fetch code can be viewed but it will not be edited. Once I make use of the pull method, pull operation, then the changes will be reflected with the help of the local copy of the code. Another operation which you must have seen when I was showing you with the Visual Studio is there is another operation which is called as sync. So there is sync, there is fetch, there is pull, and there is push. The push is currently not supported or not available, not enabled because I haven't done any changes. So let's say I was talking about sync operation. So what do we understand by sync? So sync works both ways. How? If there are any changes made on my local copy of the code, they'll be pushed to the remote repository. If some other team member or developer has made the changes onto the server side, it will be pulled. So sync will take care of both at the same time. So with the help of sync, I'll make my repository on the local side update with a single command. So this is all about the sync, the fetch, the pull, and the push methods. Let's go and have a look at another option which is available, which is the branch. I told you a bit earlier that there is a branch as a concept. So what is a branch? Branches are available with the centralized version control system, as well as it is available with the distributed version control system. A branch in the centralized version control system is a heavy affair, whereas a branch in Git is simply a lightweight movable pointer to the different commits which have been provided. So here we can see that the default branch which is created when the Git repository gets created is master. I also told you how and when the remote origin gets created. You can create a new branch by clicking on this new branch as the option. So as I mentioned a while back, one of the best practices of working with distributed version control system is keep your code which is not yet reviewed into the branches. Push your branches to the server side. Create a pull request for the branches. Get the code which you have created reviewed by one or multiple team members as per your requirement and as per policies if you have set any policy, and then merge the code to the master branch. So the branches in Git are very lightweight in nature because they can only be available onto the local copy if required. Till the time I'm not sure that I have completely finished writing with my functionality, I'll keep on committing the code to the branch which is available only to be onto my local repo. Once I am pretty sure that I have completed the part of the functionality, I would like to push my branch to the server. When the branch gets pushed to the server, the most advisable thing to do is to create a pull request so that the code which you have written will be reviewed by one or multiple of your team members. Once the team members go ahead with respect to the reviewing which happens with PR is your pull request. It is advisable to merge the branch to the master branch and it can then be deleted from the server. This is the way we can keep the server with less number of branches as compared to if I am working with centralized version control system. With centralized version control system, I do not have the facility of working on or creating a local branch. Whatever branches you create, they always get created onto the server side. So more number of branches you have, the more cluttering you are doing onto the server. Whereas here I can keep minimum number of branches onto the server side. Whenever a branch has completed reviewing facility or the branch has been reviewed, we can take into consideration and remove the branch from the server side at the time of merging. I'll show you in a while how that can be done. When I'll show you how to create a branch. So let me take this still further and show you the next parts which I wanted to show the demo for. So I'm going to create a new branch now. Yeah, so there are a few options. So let me call this branch as experimental branch. And you can see that when the branch is getting created, I have the option of checkout branch available. So what do we mean by checkout branch? Let me go back and show it to you. So if I go to branches over here, you can see there is a little difference into the master is being shown and remote origin is being shown. Master is being shown in the bold face, which is because the current working is happening on the branch. Let me create a new branch. Okay, the name is experimental, and here I have checkout branch facility available. Let me remove this for the time being and show you what happens. So now when I create the branch without selecting the checkout branch as the key as the checkbox, I still see that master is being shown in a different color, or it is a little bold color as compared to the experimental branch, which means whatever changes I will do, they will be happening to master and not to the branch which I have created. So if had I selected the checkout facility earlier, I would have seen the difference in the color. Let me show it to you. I double click on this. Immediately you will see that the master is being shown with no bold face, whereas the experimental is being shown with the bold face. So let me do a little bit change so that we can see the reviewing. So I'll say happy hours at my place and say 6 to 7:30. So it's just the demonstration changes I'm doing. So I'll click on save over here. The moment you click on save, the moment you go to the team explorer, you go to the changes, you will see here that there are changes, and you will also see that they'll be getting stored into the experimental branch. So let me give a commit message as branch and push. So I will take care of commit all and push in one go, and let's see what happens. So earlier I have shown you how commit all works. Let's see how commit all and push works. So the pushing branch is being taken care of. So it's now successful. It says it pushed the branch to the origin. So let's go back to my server, and this is where I can have a list of the branches. If I show you the branches, you will see that yes, I can see 2 branches available over here, and we can also see that for the experimental branch it is preferred that I create a pull request. So why do I create a pull request? I have written certain changes. I have done some changes to the code, and I want my code to be reviewed by my team member. So in order to get my code reviewed, I will be able to create the pull request. So you can provide the title for the pull request, you can provide the description for the pull request, and you can provide the reviewer names who will be entitled for my code review. So let me add a few names, and I'm going to also add my name so I'll be able to review the code. We will be able to create the pull request or PR like this. So here if I have a look at this, I can see that I can create it as a draft or I can just create it. So I'm going to click on create. So because I am not added, let's remove him and click on create. So I am the one who has written the code. I am the one who is going to review the code because this is going as the demonstration. So here I can go to files as a reviewer, and I can have a look at what changes have been made by the team member. So here I also have the option of providing the comments if any. So I can say that, okay, this is what I feel, this is my review comments and so on. So I can accordingly add the comments, and then I can decide whether I want to approve this code or not. Once the code is approved, I will be also able to complete the functionality for the pull request. When the pull request gets completed, let's see what is happening behind the scenes. So here what is going to happen automatically is when the pull request gets completed, it will also merge it with the branch. It will also merge it with the master, and it will also delete the experimental branch after merging. So this is what is the default behavior. So which means what? Onto the server side, there will be no more experimental branch. So which will result in decluttering of the server from a multiple number of branches. If I do not want my branch to be deleted, I can click on this delete experimental after merging as deselect. It will not happen. I want to show you how the branch gets deleted from the server side. So I'm going to use the same functionality and click on complete merge as the button. So let's see what happens. After I have reviewed the code as the reviewer, after I have completed the merge, if I go back to branches, I no more see any experimental branch available over here. I can see that all the commits have been taken care of with the help of the same master branch which is available. And you can get a little pictorial representation of how the commits happen and how the merge did happen. So this was the way where the branch was created and merged, and then I merged it with the help of the PR, which is the pull request which I created. Whereas if I take you back to my Visual Studio, in the Visual Studio, if I go to branches, I still have the 2 branches. So care needs to be taken on my local side of the code that if the branch is no more available onto the server side, either I delete it from my local copy or my local repository, or I make sure that I'm not pushing it again back. So how do I do it? I can start working with master. So whatever changes I made will be getting reflected into master. Whenever I will click on commit and push, the changes will go to the master file itself. So this is the way the remote repository will remain with least number of branches, and this is the way the branches will be lightweight because they are just available onto the local side of the repository. Let's go into the presentation. So fetch I discussed. So merge is the one which I just now showed you. So merge happens from branch to branch within the repository, or it can also happen from branch in remote origin to branch in the repository. So these are the two ways the merge is shown. I shown you merge earlier with the help of fetching the code, and at that time I said that the code will be fetched and shown, but it will not be edited. Whereas if the merge is happening with respect to the branch, then we will be able to merge it with the master branch, and then we will be able to delete the branch from the server side. So let's go into the next slide, which is for branch. So as far as branch is concerned, it creates a copy of the code for working in isolation. We are doing the development in team. I don't want my code to be available into the branch master branch directly. So in order to work with my functionality, like I said earlier, I create a experimental as a branch, continue writing my code into it till the time I'm satisfied that I have completed the part of the functionality. Then I'll be able to push my branch to the server. Then I'll be able to create a pull request on the branch, and this is the workflow for the pull request which I just now showed you. Let's take a brief recap of what I showed you. So here what happens is code is getting created, feature branch is pushed. So I have finished writing the code. I am happy with the kind of code which I have written, and I wanted to merge with the master branch, or depending upon what branching workflow you are having. So maybe there is a dev branch which is available, and not all the changes happen to the master branch. So code gets updated, the feature branch is getting created, which is the kind of experimental branch which I mentioned. I create a PR, which is the pull request, and with the help of the names of the reviewers, I am able to add the team members who will be doing the review for the code. So assuming everything goes in green color, so code and PR, that is my pull request, are accepted, then the feature branch gets merged with the master branch. So this was the functionality or the part of the workflow logic which I showed you a while back. What if the code is not accepted? So while showing you that there is a approve as the option, there is another option which is reject as the option. So a particular reviewer rejects the code, gives the proper messages. So it is a good practice again to provide as much information about the code which you are trying to reject, to give it to the developer who has written it, and so that he or she doesn't get offended. Because if you just say this is all very bad code, it's not going to be a brownie or a point earning thing. So give a proper message. This is also one of the better practices or best practices of working with Git as a version control. Give the proper feedback, and because the pull request is rejected, again the workflow comes to the same place where the code is updated. Once the code gets updated, I'll again push my feature branch to the server. Then again I'll create a pull request, and this can continue till my code which I have been writing is successfully accepted and it gets merged with the master branch. So let me take this as the opportunity to stop the presentation and go and see if there are any queries. Okay, so there are some questions which are answered. Okay, great question, Jackson. Found this. Thank you. Is the recording of the session available? I'm having a network issue. Okay, I think Himanshu will be able to answer it. Somebody has already. You can. Okay. Gated check-in concept supported. Here is the question asked by Manoj Kumar. Great question, Manoj. Direct option to gated check-in is not available, but with the help of pull request and by adding certain policies, you can get the gated check-in support. And for this, I would like to share one resource where you can get more information on it. You can follow. You can go to the site as www.netcurry.com, dotnetcurry, curry.netcurry.com. And recently I have published one article which is talking in detail about Git in general and Git on Azure DevOps. And in that I have also considered how will I get the gated check-in facility with Git. So you can do it in that. And you can create the build pipeline and DevOps for that. Where would you build occur? Okay, so Manoj Kumar, I have answered your question. So imply that I would be built additionally for the build server. Okay, so okay, Manoj Kumar, I would like to add something other than what Kunal had said. If you are using Azure DevOps for your experimental perspective, you might be also aware that up to 1800 minutes of build time are free for a month. So if you are doing it for exploring perspective, then okay, 1800 is a huge time. Another thing is, in case you don't want to work with a hosted build, you can create your own default build, and then you will not be billed for the build server because you will be working with your own build agent. If it is Azure DevOps Server 2019 on premises, then this build happen on prem, right? Yes. Sure, Sivraj, that's the correct one. Azure DevOps Server Express, the free version for individual, no cost, easily install. Okay. What else? Okay, I already answered about the gated check-in concept by saying that okay, it's not a straightforward gated check-in, but yes, it is possible. If it is okay, that's why I already answered how to deploy to Azure from GitHub. Okay, Ashish, to answer your question, how to deploy to Azure is there is a little confusion in the question because if you say Azure is a different set of services. If you say Azure DevOps is having the built-in connectivity to to GitHub. So if you are saying about Azure, which is the Azure services which are available from portal.azure.com, then yes, you can also do that, but you'll have to create a webhook for that. We have UAT branch, pre-production, and prod branch, and we want to merge UAT with pre-prod. If pre-prod is auto merge with prod. Okay. Pipelines can also take GitHub repository as a source. Yes. Can you show an example of deploying on Azure from GitHub? Ashish, unfortunately, I won't be able to show you the demonstration right now, but if you can send me a mail, which I'll share at the end of the session, I'll send you the link where you'll find the information about it. You can do anything, you just need to try pipelines for one. Okay, it has unlimited possibilities. Let's say deploy a Azure function from GitHub to Ashish, your function deployment from GitHub to Azure. Yes, it's possible. You go to Azure and go to the deployment center over there. There you have the option of selecting the source control. The source control can be Azure DevOps. At the same time, it can be GitHub also. You'll have to create a GitHub webhook in GitHub, and then yes, you should be able to do it, Ashish. Can you show an example of deploying a Java Azure function to Azure from GitHub? Well, Ashish, these examples are pretty what I can say, taking a more time, but I can point you to a resource wherein I have not done it deploying from Azure function to Azure, but I have done it from deployment for a Java application from Azure DevOps to Azure, and that again you will find it on .NETCurry.com. Okay. Please go ahead with any messages, or I will be wrapping up my session in a bit. So, okay, Kunal has already sent some resources about pipelines and okay. So you can check on www.netcurry.com and go under the tutorials for Azure DevOps, and there are some tutorials under DevOps also where you will find a lot of functionality and a bit of the questions which Ashish Goyal is asking. So you can try out this resource. What else? Okay, so that seems to be pretty much as far as the chats are concerned. Let me go back to okay, so let me take a quick recap of what we have done or what I have discussed with the help of the session. So we started discussion by finding out what is a version control, and I told you two different ways with the help of which version control can work, and one which is pretty straightforward as centralized version control. I told you some of the tools with centralized version control and the pros and cons of centralized version control. Then we discussed distributed version control. I showed you a bit of the tools from DSVCS, and then we discussed a little bit details about Git as a version control, and then we discussed some basic operations. The basic operations we discussed were how do I first clone the repository, what is a repository. There is a shared repository onto the server side which is always available, but every developer will have the copy of the repository on his or her own machine. Then we discussed what is commit and how will I be able to commit locally, because the commit normally happens locally. It becomes very fast to work with distributed version control system. Then we also discussed three facilities with commit and push, commit and pull. I told you the differences between push, pull, fetch and sync. Then we also discussed what is a branch, how a branch can be quickly created, and why a branch in Git as a distributed version control system is lightweight. And we also discussed how a branch can be created, how a branch can be pushed to the server, and how I will be able to create a pull request, get the review done for the branch, and then decide based on whether the pull request is accepted or not, whether to merge to the master branch and remove the unrequired branch, so as to keep the server less cluttered with the more number of branches. So please go ahead with any queries. As Himanshu has already mentioned that please put your queries into the queues over here. I will also share my mail. So this is my mail ID. You can write on to me, and another resource which I have provided to you is, please check out on this resource and you will get a lot of articles onto this. So you can note down the mail and you can note down the resource which I have shared. So yeah, thanks Kunal. That's my mail, gourisoni@hotmail.com.
Sorry, are we done? I guess I see you have already answered all the questions.
Yes, I have already answered all the questions. Yes.
That's good. So then I guess then
okay, there is one more query. Could you please share the PPT? Okay, it will be anyway available with the recorded session, right?
Yeah, it will be there in the session. So yes, that'll be fine. Perfect. Then I guess we don't have much questions. Then let's not take much of your time. And
sure.
thank you very much. I guess.
Yeah, thanks a lot. Even I enjoyed the session, though I was a little tired today. I've been conducting training since last Monday, so I didn't have any break any time. Okay, nice talking to you all.
Same. Thank you so much, Gouri, and do let me know if there are any more sessions you have for future.
Sure. I'll definitely come back to you with the next session. Okay, bye, people. Have a great evening. Calling off. Bye.
You too, sorry. Thank you, everyone. Thank you for joining in, and again, once again, thanks to Himanshu and Kunal for all the help and all the support. We are doing sessions every week again and again, so don't miss out on them. These are like really curated ones, so try to be there. It's like because this is for your own good and nothing else. So be it 10 people or be it 100 people, we'll be running the same session with the same enthusiasm. So be there, make the most of it, and yeah, see you next week. Thank you so much.